So now let us find our radian measures. So this is the slide what you have from the end of 8.3 lesson part 1. So for the radian measures, so we are going to say 0 degrees is 0 radian. And if you go to 180 degrees, which is a semicircle, that's going to be pi radian measure. And if we go through the entire circle, we are going to land on 2 pi. So 0 and 2 pi will be in the same place. So you can see if you go all around the circle, here is your pi, and here is your 2 pi, which is the same place as your 0 degrees. So now let's go ahead and look at some other angles. So for example, let's look at the 90-degree angle in radian measures. The 90-degree angle is half of 180, so that's going to be half of pi. So this angle here is going to be pi over 2. In other words, it's half of pi. If we go to the pi, which is your 180 degrees, that's 2 half pi's. And then here is my 3 half pi's, so I need to put 3 pi over 2. And then the 4 half pi's are going to be my completed 360 degrees, because in 2 whole there are 4 halves. So now we are going to also check some other angles. In other words, we are going to check the multiples of the 45-degree angles. So if I'm going from 0 to pi over 2, halfway between that is going to be my 45-degree angle. So half of a half is going to be pi over 4. So 90 degrees is 2 quarters, in other words, 2 times 45 degrees, which as a fraction is going to be 2 pi over 4, which reduces to pi over 2. Then here if I go to 135 degrees, that's pi over 2, which is 90, plus the 45, pi over 4. So that's going to give us 3 pi over 4. And pi, when we end on 180 degrees here, that's going to be 4 pi over 4, which is just pi. So let's move to the next one here, which is going to be 5 pi over 4. Then we move to 276 pi over 4, which is 3 pi over 2. And then 315 is 7 pi over 4. And last we'll get to 360 degrees, or 2 pi, which is 8 pi over 4. 8 divided by 4 is 2, so that's how we get 2 pi. So now we are going to move to multiples of 30 degrees. Well, 30 degrees is 1/6 of 180 degrees. So this is going to be pi over 6. Then here in 60-degree angle, we'll have 2 pi over 6, but then we can reduce that to pi over 3. Then here on the next one, which is 90 degree, is going to be 3 pi over 6, which is pi over 2. So then here on 120, we'll have 4 pi over 6, which is 2 pi over 3 if we reduce. So that's 2 pi over 3. And then here on this one here, we are going to have 5 pi over 6. And then pi is 6 pi over 6, which is just pi. So then here we'll have 7 pi over 6. Then here is 8 pi over 6, which is 4 pi over 3. Then 9 pi over 6, which is 3 pi over 2. Then we have 10 pi over 6, which is 5 pi over 3. and then we'll have 11 pi over 6, which is going to be 330 degrees, and 12 pi over 6 gives me 2 pi. So currently we just went around the unit circle and converted every degree measure into radian measure. You can also convert all of these degree measures using the formula. So if you want to do degree to radian, then you're going to take the degree measure and multiply it by pi over 180, and you will arrive at the exact same answers if you reduce the fractions. So now let us figure out the ordered pairs for the points that are on the terminal side of the angles and or right on the circle. So I'm drawing a few of them here. So let's go ahead and start with our first quadrant. So this is our first point. I will actually begin with the 30-degree angle. So I'm going to make a right triangle where the angle theta is going to be the angle in between the x-axis and the terminal side of the angle where I put the arrow. And the measure of this angle is going to be 30 degrees. So obviously the measure of the other angle here is going to be 60 degrees. So we are talking about a special right triangle. So if the radius, which is here, is equal to 1, then I am going to my special right triangle that I need the information from. So in this special right triangle right here, the radius is 1, which is the hypotenuse of the triangle. So the side opposite to the 30-degree angle will have a 1/2 value, and the side adjacent to the 30-degree angle will have a √3 over 2 value. So I am going to look at my y coordinate, which is here, and the y coordinate of this point is going to be 1/2, and the x coordinate of this point is √3 over 2. And this comes from looking at sine 30 is opposite over hypotenuse is a 1/2 divided by 1. And cosine 30 is adjacent, √3 over 2 divided by hypotenuse, which is √3 over 2. So from here, I can say that the ordered pair x and y is going to be really cosine and sine values, where the x coordinate is the cosine value and the y coordinate is the sine value. So now let us make another triangle for the 45-degree angle. So again, I am going to make my right triangle with right angle being on the x-axis. And so then the angle here is going to be 45 degrees because my terminal side is on the 45 degrees. So that means the triangle's second angle is also going to be 45 degrees. So to decide in this case what the ordered pair is going to look like, I have to go to my 45, 45, 90 right triangle, and I can see that the y coordinate, which is going to be opposite to the 45 degree, as well as the x coordinate, which is the opposite to the 45 degree, is going to be the square root of 2 over 2 as well as the square root of 2 over 2. So both of the legs of the triangle are square root 2 over 2. So now we are moving on to the next angle. So we are going to move to the 60-degree angle. Before we move to the 60-degree angle, let me write radius equals 1. So for the 60-degree angle, again the radius is 1. If I draw my right triangle, The right angle is right on the x-axis, and the angle here measured in red is going to be 60 degrees. That means we are back to our 30, 60, 90 right triangle. However, we are going to look at everything in relationship to the 60-degree angle. So the x-coordinate is going to be the cosine, right? The cosine value of 60 degrees. So the cosine of 60 is 1/2 over the hypotenuse, 1. So let's go ahead and write that, 1/2. And then we move back to find the sine value of 60, which is opposite over hypotenuse. So it's √3/2 divided by 1, or just √3/2. So now we'll move to the last angle in this first quadrant, is actually the angle of the 90-degree angle. So when I move there, I can see that the 90-degree angle is right on the y-axis, and here's our x-axis, right? So on the y-axis, so the x-coordinate will be 0, and since the radius is 1, our y-coordinate is going to be 1. So from here, all we need to do is find the ordered pairs in the other quadrants of the coordinate plane. So I am just going to use reflection to find the values. So if I reflect this green ordered pair, which is √3/2, 1/2, over the y-axis, I land on the angle of 150 degrees, or 5 pi over 6. And the only thing that will be different from the other ordered pair, so I'm going to write √3/2, and I'm going to write 1/2, is that since I reflected over the y-axis, my x-coordinate is going to become negative. Now I move to the second point, which is going to be √2/2 and √2/2. Again, if I reflect it over the y-axis, my x-coordinate will become negative. So negative √2/2 and √2/2. And this is going to be my 135-degree angle. So now we are moving on to the following angle, which is the 60-degree angle. So if I reflect the 60-degree angle over the y-axis, I get to 120 degrees, which is 2 pi over 3. And my ordered pair is going to be negative 1/2 and √3/2. So now we are going to do our reflections over the x-axis. So the first point I am going to pick here is the 150 degrees. I reflected over the x-axis, so it will become 210 degrees. And now I'm in quadrant 3, so both parts of the ordered pair are going to be negative. So negative √3/2 and negative 1/2. Then I move to my 135-degree, and if I reflect it over the x-axis, I get to 225 degrees, and again both parts of the ordered pair will be negative. So I'm going to have negative √2/2 and negative √2/2. And then I move to my last point to reflect in this quadrant. So I'm going to have the 120 degrees, which will reflect to 240 degrees. So both of the numbers in the ordered pair are negative. So negative 1/2 and negative √3/2. So now we are going to move to find 270 degrees. Again, we are on that y-axis, so our x-coordinate is 0. And the y-coordinate is going to be negative 1. So let's go ahead and start reflecting. So we are going to reflect our 60-degree angle to 300. And in this case, our x-coordinate is positive and our y-coordinate is negative. So it's going to be 1/2 and negative √3 over 2. Then we move to 45 degrees, which reflects over the x-axis to 315 degrees. So that's going to be √2 over 2 and negative √2 over 2. And the last angle is the 30-degree angle. So we are going to reflect the last order pair. So that's going to give us √3 over 2 and negative 1/2. As you notice, we only have two angles that we haven't filled in. One of them is 0 or 2 pi, and the other one is the 180 degrees or pi. So if I look at those, at 0 degrees, or at this point right here in the unit circle, I know that this here is a radius all the way to the point. So this is a radius of 1. So the x-coordinate is 1, and your y-coordinate, since the point is on the x-axis, is 0. And if I move to the opposite side here, I can either reflect the point over the y-axis, I can reflect it over the y-axis, or I can just go through the same process and figure this one out here. So the point, since this is here is a radius, it's going to be -1 since we are on the negative side of the x-axis, and the y-coordinate is 0. So now let's look at where each one of these trigonometric functions are positive and which quadrants. So we know that this is quadrant number 1, and we can see that sine is positive, cosine is also positive. We can see that in quadrant number 2, sine is going to be positive. However, cosine is going to be negative. In quadrant number 3, which is going to be right over here, we can see that sine and cosine are negative. So sine and cosine are negative. And in quadrant number 4, which is our last quadrant, we can see that sine is negative, but cosine is positive. Now let's look at the reciprocal functions. So the reciprocal of sine is cosecant. So if sine is positive, cosecant is also positive. And the reciprocal function of cosine is secant. If cosine is positive, secant is also going to be positive. Then we move to quadrant number 2. So sine is positive, therefore cosecant is positive. However, cosine is negative, so secant is also going to be negative. Let's go to quadrant 3. In quadrant 3, sine and cosine are negative, so cosecant and secant also will be negative. If we go to quadrant number 4, cosine and secant, the reciprocal of cosine is going to be positive, and sine and cosecant are going to be negative. Now if we look at the tangent function, the tangent function is tangent theta would be y over x. Since we can see that it's y over x and y is sine, so we can say tangent theta is nothing else but sine, and the x value is cosine, so it's sine over cosine. So now based on this information, we can decide if tangent will be positive, negative in any of the quadrants. So if I'm looking at the first quadrant, Both sine and cosine are positive, so that means tangent will be positive, and its reciprocal, cotangent, will be positive. Now if you look at quadrant number 2, sine is positive, however cosine is negative, so that means their ratio is going to be negative. So I will have to say tangent and cotangent are both negative. In quadrant 3, sine and cosine are both negative, so a negative divided by a negative, or the ratio is going to be positive. Therefore, tangent will be positive and cotangent will be positive. And in quadrant number 4, cosine is positive but sine is negative, so the ratio is going to be negative. So over here, tangent and cotangent will be negative.